Do a quick round of introductions. My name is Alagappan, Al for short. I'm an account manager with Amazon. I focus on south of India. I'll introduce the rest of the team in the room so we can talk to us all later. Kingsley Wood, the star of the show. He's a AWS veteran. He's been with us for a long number of years. He has gone through the most complex customer requirements and issues, and he's a great resource for you to talk to, ask your questions. We have Joe Ziegler, who's our new APAC evangelist. We have in the back, we have YC, who's our marketing all-star. If you have any questions around your credits, please feel to reach out to him. We have Shailesh. He's our new SA. He just joined as of yesterday, so it's trial by fire for him right now. Everybody should have a feedback form. If you fill out the paper feedback form, good for you, you get $25. But if you actually fill out the electronic feedback form, you get $75 because we do want to save papers, trees, and the environment. So without further ado, Kingsley Wood.
All right. Okay. Thanks very much, Al. All right, just to get started, I'd like to acknowledge that we have a whole crowd of people tuning in online. So thanks very much for those signing in online. I'm going to ask you guys this time is really important, if you can just silence your phones and switch them off if possible. There's a lot of interference that can go in because we're going to be live online. We want to make sure that webinar goes through. So if you wouldn't mind just switching off your phones, I'd appreciate it. Also, just a bit of housekeeping. The bathrooms are outside. The exits are that way and that way. So just to let you know. Let me introduce myself again. I'm Kingsley Wood. I joined Amazon about 4.5 years ago. And I moved out to Singapore 2.5 years ago when we opened our first region in APAC. Since then, we've opened several regions. I'll get into that in a little bit more detail as we go through this. But I'm in charge of business development for the compute side of our business across APAC. So that's where I'm coming from. And I'm going to be talking to you a little bit about Amazon Web Services. Now, a lot of you are probably wondering, why is there someone from Amazon talking to you about cloud computing? That's a good question. Who here is a customer of Amazon.com? How many of you have actually purchased a product from Amazon.com online? Wow, thank you. Fantastic. So you're all our customers. So we've got some important information on you, if you think about it. We've got your credit card. We've got your address. We know your shopping habits. And I'll explain to you a little bit later why that's important. But bear in mind that we've got some personal information on you. That's as part of Amazon.com. Now, the company Amazon.com began 16 years ago, and we started selling books, and then we started selling CDs, and we sold DVDs, and we started selling a lot of things. And we got really good at selling a lot of things. And as part of that evolution, we learned how to control the data that manages all those purchases. In the US, at times, we've had peaks of 80,000 credit card transactions per second. That's the sort of volume that we see Christmas time when Americans go crazy with their shopping. So as we got good at selling things, we decided to evolve the business a little bit to actually create a business where we helped other people sell things. So we managed the shipping, the handling, the logistics, the data, the transactions, the product lists, etc. That's where our second business, the seller business, actually evolved from. So we got really good at maintaining all this data, but controlling it in real time, doing all the logistics and so on. And as part of that skill, about 5 or 6 years ago, we realized that a lot of these IT capabilities that we were developing were actually marketable as a product or service for other customers to run any aspect of their business. So that's where Amazon Web Services evolved from. It's our ability to manage the data centers, all the data that goes back and forth, and the logistics of actually handling all these huge transaction volumes. So that's where Amazon Web Services actually evolves from. So what I'd like to do today is give you an introduction to cloud computing. If you leave with one thing that you didn't come in with today, I want you to understand better what is cloud computing. Right? You hear a lot of the buzz. Everyone's talking cloud, cloud, cloud. We want to give you our perspective of what cloud computing is about. The second thing I'd really like you to understand is Amazon Web Services and what actually entails the whole world or the universe of Amazon Web Services and what we can give to you, offer you to run your business more efficiently. We'll go through a whole bunch of success stories. We'll talk about what's unique about Amazon. I'll give you a bit of a very, very quick demo just to get an understanding. But during all of this, we're going to be flip-flopping back and forth between very technical discussion and not so technical discussion. So don't worry about it. We're just going to kind of meander back and forth along that path. But we want you to get an understanding of cloud computing and Amazon Web Services. That's the objective today. And we very much appreciate your time and investing your morning with us so that we can convey this message to you. And again, thanks to everyone for tuning in online and dialing in so we can actually give this message to a lot more customers across APAC. All right, so let's get started. What we're going to try and do is give you an idea of these 5 tenets. These are what we believe you should be looking for when you're thinking about cloud computing. Okay? We'll go into each one in a little bit more detail, but bear in mind that this is Amazon Web Services' viewpoint of cloud computing. The first one is elastic capacity. What does this really mean? If you have an IT infrastructure need, what we want to make sure that you do is have the ability to add and subtract capacity and infrastructure when you need it, right? So in terms of what that actually means for your infrastructure on tap, you need more infrastructure now. You want to be able to add to what you have. But just as importantly, you must be able to remove it. The reason is that when you don't use it, when you don't need it, you don't want to have to pay for it, right? So the elasticity, what we're talking about here, is the ability to add and remove infrastructure. Bear that in mind throughout this whole discussion. If you look at some of the current capabilities of an IT world that you might have, your own data centers, your own systems, you can't necessarily be that flexible. You can't add and remove capacity when you want it. So we try to give that to you in a very dynamic form. If you look at this in a graph sense, over a period of time, your infrastructure needs are going to go up and down. A typical use case is this, where your IT trends are up and down over a period of time, any period of time. Traditionally, you're expected to buy as much capacity as you need to handle the peak loads, right? That's that hard line at the top there, right? What really happens in a lot of these use cases is if there's a fast growth, if there's variable peaks, predictable peaks, etc., these are different use cases. All of them have different spikes, different peak loads, right? All of them require, with traditional IT, for you to build and buy enough IT infrastructure to handle your worst case scenario. So what does this lead to? It leads to a lot of waste, right? Every time you've got more infrastructure than you need, you're not using it, it's a waste, all right? A classic example, think of yourself buying a brand new, beautiful Ferrari, and it sits in the garage. Now you've got to go to work. You're not driving it, right? So it's a waste. It's not being used at all. What we try to do here with the elasticity is take the capacity back when you don't need it, so you're not paying for it. So bear that in mind here. So there's all these scenarios where you've got a lot of growth, you've got a lot of peaks that you can actually predict, but you don't need the capacity all the time. And that's why elasticity is so important in the cloud computing world. What's even worse scenario is in this one down the bottom left here. Imagine if you've got more traffic than you can actually handle right now, right? You can't call up your hardware vendor and say, hey, I need 20 new machines. Well, when do you need them by? I need them in the next 30 minutes. Not going to happen, right? With cloud computing, you can get that capacity on demand when you need it, right now. That's the beauty of this, the actual speed with which you can implement it. There's no need to provision ahead, to predict ahead when you're going to need the capacity. You just absorb it when you need it, make a call, make it happen through an API call or a web console, click, 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 and it happens. You get the capacity you need. So that's what we're aiming at. So what cloud computing addresses is the flexibility, the elasticity, where we actually follow your demands by providing you what you need at the time you actually need it. So now you've got this beautiful red line that actually trims just above your actual capacity needs. And if it's a scenario like some of these fast growth variable peaks, think of a month-end payroll system, right? You know the last 3 days of every month you need to process that payroll. But for the rest of the month, there's no need for it. So you can actually predictably see when your peaks are going to be needed. You can add capacity then and remove it the rest of the time. That's our elasticity, so bear that in mind. The second big tenet we talk about is the quick and easy deployment. This is the ability for you to get it without having to go through a whole lot of process, all right? We, as salespeople within Amazon Web Services, would rather that you didn't call us when you needed capacity. We don't want to be a middleman blocker, right? If you need it, go ahead, go online, request the capacity you need, make sure that you get it straight away. We don't have to get involved in it. There's no faxes to fill out or performance or checks or anything. We just want you to get the capacity when you need it right away. And that lets you focus much more on your business, right? You can get back to doing the job that you want to do without having to wait for that capacity to come about. So that's a real easy way for your IT infrastructure to expand and contract on demand without having to involve anyone in the middle. All right? Now let's talk about money. What is it all about the CapEx, right? No one wants to spend that money up front when you're not quite sure how much you're going to actually need, right? This is the beauty of the cloud computing model, is that we don't require any investment up front. There's no setup fees, there's no termination fees. You can leave anytime you want, you can come back anytime you want. So it's highly flexible. And this means from a money point of view, you haven't committed yourself to spending huge amounts before you know how successful or busy the project will be. Which leads me to my next point, and this is the real foundation of cloud computing, it's got to be a pay-as-you-go model. Everyone knows when you switch on the light, on comes the power. Switch it off, and you're going to switch it off, you don't have to pay for it anymore. I liken it to getting in the shower in the morning. You're going to go to work in the morning, you get up, you get in the shower, and you go to work. You're not going to leave the shower running all day, right? That would be a waste of water. So you switch it off when you don't need it, you go to work. That's the concept that you've got to think of in terms of cloud computing. Because it's pay-as-you-go, we charge in 3 separate ways, and this is important to note. We charge per hour for the compute capacity that you use. Depending on the machine, it'll be more expensive or less expensive, depending on the memory or the space you need, but we only charge by the hour, which means if you use it for an hour, switch it off, there's no more commitment after that. It's that flexible. That's the granularity. Secondly, on the storage, we charge per gigabyte per month. This is a very important concept from a long-term storage point of view because you're not provisioning a huge amount of space ahead of time. You don't have to know that you're going to need 1 terabyte of space. Just use a few gig when you need it, add it, and remove it. But we'll only charge you for how much you've got stored. So liken that to buying a traditional big hard drive. You bring it home, you're paying for it on day 1, even though it's empty. And how fast you fill it is up to you, but you're paying for it the whole time. With Amazon, there's a limitless bucket that you can just throw objects in, and we'll only charge you for how much you've actually got stored in your bucket at any one time. The third and final cost category that we talk about is the transmission of data from Amazon out. Now, you can put as much as you like into Amazon. We don't charge you, right? You can pump it in as fast as you like. We'll absorb it. When you want to send it out, we charge you per gigabyte delivered, which means if someone's watching a 100 meg movie and they only watch the first 10 meg, we'll only charge for the first 10 meg. So we only charge for how many bits are actually delivered to the endpoint. And we'll talk about how the endpoint is distributed worldwide and so on in a minute. But just to bear in mind that you're only paying just the amount that you actually use. That's the real pay-as-you-go model. Very, very effective. Because no one wants to pay for a whole bunch of delivery that you might do or might not do, right? You're only paying for what you actually use. So that's a very important model. All of this evolves into one final impact on your business. This is the ability for you to automate and focus on your business. We don't want you to waste time with IT undifferentiated heavy lifting. This is our fancy term for the boring stuff. Setting up machines, setting up network, installing software, making sure the updates are correct, right? All of these things take a huge amount of time to do, and they're boring to do. We want to take care of that for you. So think of the IT headache. We want to take that away from you. If you can think how that impacts your business, you can now focus on what your business actually does. Because very few of you are actually in the IT business itself. You're making products, you're servicing customers in different ways with different products and services that aren't IT directly related, but if we can do the IT part for you, we can make you more efficient for that. Makes sense? So all of these come together in these 5 tenets of cloud computing. This is our view of cloud computing. Make sure when you're evaluating a cloud provider and you're thinking about products and services that are labeling themselves as cloud, do they really provide this kind of benefits to you? In terms of business benefits, this is really how it translates. You're going to lower costs as a result of this. You have to. Your utilization goes up. By utilization, I mean the efficiency with which you're using the infrastructure that you're using from Amazon. Make sense? If you can do all that sort of thing, you're able to focus on your business, which must make your business more efficient. And that gives you more of a chance to do the things that are impacting your customers versus just boring stuff that no one notices. That's the IT stuff. Let us take care of that. All right. That's an introduction to cloud computing. Let's now go on to Amazon Web Services itself. So what we want to talk about here is, without getting into too much detail, is the building blocks that actually make up AWS. Who here has actually used AWS, used some of our services? Some of you? Good. So you might be aware that if you're on a newsletter, you get an update almost every week with new services, new products, new features. It's constantly evolving. This is very exciting for us. We've added several products and features over the last few years that enhance the ability for people to use the infrastructure in the cloud. So we think of ourselves as infrastructure as a service. We're providing infrastructure on tap, on demand. In terms of the architecture worldwide, as El's talked about earlier here, we've got several regions around the world. Now let's just make sure that we understand what these terms mean. A region is a collection of availability zones. So each region you see up there is actually divided into multiple availability zones. An availability zone is a distinct data center. Separate building, separate power supply, separate connectivity. So you'll see in all of our regions we have at least 2 availability zones. What that means is that if your data is spread amongst 2 availability zones in any one particular region, for instance in Singapore, if you've got some stuff in A and some stuff in B, That's fine, but if you can distribute your content across both availability zones, if one was to go down, unavailable, even if the building burned down, all your data is still safe in the other AZ. So in terms of encapsulation, your data is contained within a region, but spread amongst multiple availability zones. In addition to these availability zones and regions, we have 33 edge locations around the world. And most importantly, for APAC, we just announced the newest one in Sydney. That was just a few weeks ago. What these edge locations do is distribute the content to the user, the end user, that's best for them. And we call this latency-based routing. If a user is sitting in Sydney and my data is actually stored in the Sao Paulo region, we will move the data originally from the region where it's stored to the edge location closest to the user and then deliver it to the user. What this means is that the second user in Australia doesn't have to go back to Sao Paulo to get the data again. Right? It's a content distribution network. The content is then delivered directly from Sydney very, very quickly because it's already there. And this dramatically improves the user experience for the end user. Every end user around the world is going to be closest to one of these. We'll work that out with latency-based routing. And by doing that, we're leveraging our content distribution network to deliver the content straight to the end user where they're closest to. Make sense? What this also means is that you have a global reach immediately. By using any part of Amazon Web Services, you can extend the control of your data to spread it worldwide right away, which makes every small company, whether you're one person or 1,000 people, you can make your company global and distribute your content to a global audience just like that. And I'll show you in a minute how we do that with a brief demo. So how do we let people use our products? It's very easy. We simply require you to sign up for an account, which is free to set up. You provide us your credit card and phone number, and your account is activated. Remember earlier I asked you about how many of you had actually shopped on Amazon already. You already have an account. You can use that same account because we have your credit card and phone number, we validated you, and you can start using Amazon Web Services straight away. Or if you want to create a new account, you can do that. So in terms of this eye chart, don't worry about this. This is what I call it the alphabet soup. We've got all our products, EC2, RDS, S3, etc. What it really, really summarizes down to is 4 main components: compute, database, storage, and networking. And if you think of those 4 components, all of our products fall into one of those. And just some of them that we'll be getting into now is EC2 and S3, the storage, the compute side. All right. So now let's move on and talk a little bit more about the details, and this is where we get a little bit more technical, about how you actually manipulate your infrastructure in AWS, how you use it, how you leverage it. So we're going to talk about originally the access of the user to AWS. Now there's several ways that you can use it. I will show you in a demo in a few minutes the web console, which is simply a web browser. You log in, you make sure it validates you, and you can do most of the services. But in fact, that's only 10% of the capabilities of AWS. Much more detailed and rich than that is the API, the SDK, and if you're willing to write scripts and get down into the technical details, you can use the command line interface. All of these access points allow you to control the infrastructure that you have anywhere in the world at any of our regions. So whether you're sitting here in India or in China or in the US or in South America, you can control infrastructure in all of our regions just the same. Now, the infrastructure control allows you to manage the actual systems in place in those data centers, in those regions. And this is a summary of what we're actually looking at. If you have a look at some of our product in detail, we have products like CloudWatch, which actually monitor all your infrastructure, send back signals, and manage the CPU utilization or the network traffic in and out of the devices that you've chosen to spin up. That can then be used to take action. You could say if the CPU utilization goes above 80%, take an action to increase the amount of instances you have running your application. If it goes below 30%, switch them off. So you can automate the process of saving money. Remember the elasticity that we talked about? You can actually manipulate the amount of infrastructure you have based on rules that you set up or thresholds that are crossed here. We have a whole bunch of other systems. I won't get into too much detail here, but for instance, CloudFormation allows you to describe in a text JSON format a full infrastructure, including your compute, your databases, your load balancers, everything, and then deploy that in various regions very, very quickly. So there's much more automation and much less duplication of effort. And this gets back to the undifferentiated heavy lifting we're trying to take away from you. Get rid of the headache of IT management. So below that service layer, we have what we call the platform building blocks. Now these are extensions of our core infrastructure building blocks that allow you to do things much more efficiently that have been taking a lot of time. Some of the acronyms here, like SES, Simple Email Service. We have customers, for instance, in Taiwan that send out 1 million emails a day for their daily offer. Now, there was a problem with this because sometimes the emails would get delayed, sometimes they would choke on the system, and the system wasn't able to handle the capacity. People were getting the daily offer from Monday on Wednesday. That doesn't work, right? So they wanted to automate the whole process where they could get this huge bulk of email out and not have to worry about it. Now they're using SES, and it gets delivered on time at noon every day. So they deliver the email to us. We then take the list of their people that they're sending it to, and we deliver it for them on their behalf, right? And it's using our IT infrastructure that's been growing and building in order to handle our massive load of things like Amazon.com. You can imagine how many emails we send out with orders and shipments and so on. We can leverage that infrastructure to help customers like that use our infrastructure better for their customers. Some of our databases we'll get into, DynamoDB, RDS. These are ways that we've tried to look at some of the repeatable tasks that a lot of you are doing with database management, which can be a real pain, and we try to take that away from you and do it for you. So we automate it or manage the databases on your behalf. Below all the platform is now core infrastructure. And this gets back to those 4 building blocks I was talking about, the compute, the database, the storage, and the networking. And if you look into some of these concepts like EC2 and S3, these are the core systems that run by the hour for compute, by the gigabyte for storage, and by the gigabyte for delivery. And all of this together maps out our Amazon Web Services universe. So it gives you some idea of the concepts here. All right, enough technical talk. Let's talk about who's actually using this. Who's actually making this work for them in order to save themselves money and make their companies more effective. And you're going to recognize some of these names because these are really big companies, and we're very honored to have these as our customers. If you look at a company like Shell, massive deployment of infrastructure worldwide. They have an incredible number of developers and marketers and researchers and analysts using infrastructure. Their CTO has said no more physical hardware. We don't need to. We're going to do everything in the cloud. So they've mandated that all new infrastructure requests go to the cloud. What does this mean for them? This means they can avoid all the infrastructure costs of getting involved in vendors and making sure that the product gets delivered. Does it get delivered to the right spot? Is it set up with the right networking, and et cetera, et cetera? All that's taken care of in terms of using AWS instead. So their employees now requisition infrastructure by going straight to the cloud. And when the project's over, they can switch it off. They're not paying for it anymore. They're not left with a whole bunch of machines under their desk that aren't being used. That's a real efficiency gain. If you look at a company like Samsung, everyone's seen these ads for all their new smart TVs and so on. All of that is being run on Amazon Web Services. So every time one of those devices connects to the web for an update or a firmware update or software or connectivity, it's all going through AWS. And they claim to have saved $34 million just in the last year by transitioning everything to AWS. Why? Because they make great TVs, they make great devices, but they're not an IT shop. There's no need for them to manage the headache of doing all the infrastructure and IT. In terms of media and deployment, you'll recognize some of these names as well. Netflix, Animoto, PBS. They use Amazon Web Services so that they can focus more on their business. Some amazing stories for companies like Netflix, which apparently now accounts for over a quarter of the internet traffic in the US. That's a substantial amount of data, right, being transferred back and forth. But their magic is about making your user experience as a viewer better. Some interesting stories there. They have analytics that even watch when you're watching a movie on Netflix. If you think about it, you click on a movie, you start it up and you run it. Let's say towards the end of the movie you fall asleep, right? The movie's going to go right to the very end and then stop. They measure that. Because if you are paying attention, if you were enjoying the movie, as soon as the credits come up, you stop the movie and then you go to the next movie, right? So they can track that and say, well, this guy likes this movie more than he likes that movie. And they can use that to give you a better recommendation of your next movie you should watch. So think of little details like that. Now, if you've got 1 million users watching 1 million movies, that's a lot of data flowing in and out. But they use all of that on AWS. They're not running huge data centers to manage that. And that lets them focus on the magic of providing entertainment. If you think about how many movies they have to convert, every time a new movie is released, they need to convert it to something like 28 different formats. So it's viewable on an iPad, on an iPod, on PS3, Xbox, etc., etc. All of that conversion takes a lot of compute energy, right? A lot of computers have to be spun up to run it. Now, it wouldn't make sense for them to spin up 1,000 machines And then when the movies stop coming in, they've still got the machines. But with Amazon Web Services, they can just use the machines they need at the time and then shut them down and stop paying for them. Very, very efficient use of that. Some weeks they'll have a lot of movies. Some weeks they'll have a few movies. So it's an infrastructure elasticity again. Anyone heard of this company, Animoto? Very, very cool company, yeah? You go on holiday, you take 100 pictures. You send them those 100 pictures, you choose a piece of music, and what happens is that they then create a music video of your holiday for you. It makes you look like a rock star, right? All the transitions and the fancy beats and so on. Now, what happens when you share that movie with someone else, with one of your friends? They'll want to make one of those movies as well, right? This is exactly what happened. They shared their app for free on Facebook. And they literally went from 50 to 5,000 servers. And when I say servers, I'm talking about virtual machines in the cloud, right? They went to 5,000 servers in just 3.5 days. Tremendous growth. Now, I want you to visualize what it would be like if everyone in this room got together, and probably everyone online as well, and we got together and we carried 5,000 machines into a data warehouse. And you do the database, you do the networking, you do the installation, and you do the updates and so on. We wouldn't get it done, right? It's impossible. So it's an amazing success story of how they were ready to go on the cloud so that when the surge took off, when the spike of interest and traffic took off, they were able to handle it. Very important thing to notice about this curve. It goes down, right? After 3.5 days, the hype was over. The word had spread. People had tried it out. Okay, fine, that's fine. The machines started switching off. What does that do? It means they saved a lot of money. Because if they'd hauled 5,000 machines into a data warehouse, on day 4, they'd be sitting with a warehouse full of machines that aren't being used, right? Much, much more efficient modeling. Everyone's heard of these fancy terms like big data, HPC, high-performance computing, analytics, and so on. A lot of these companies are very, very pleased to be able to use infrastructure in the cloud, which doesn't mean they're committing to huge amounts of expensive infrastructure that they don't need after the job is done. All right? You look at some of our customers. We're very proud to have NASA. Anyone who can pronounce this very quickly, I'll be impressed. All-terrain hexalimbed extraterrestrial explorer robot. But that's some of the technology that they're using is very, very intensive on needs of compute. Right? They've got huge amounts of data flowing in from some of their exploratory robots and so on. Where do they store that? How do they process it? It's all in the cloud. They can use the cloud to do it much more efficiently, but also quicker. If you can spin up 1,000 virtual machines and do it in 10 hours versus having to wait 1,000 hours to do it on 10 machines, that's more efficient. You can get an answer back. You can make a decision quicker. So it's real great benefit for them to be able to do that. And again, once the project's over, they switch the machines off. We use them for someone else, but they're not spending money on infrastructure that's no longer being used. Okay. What about archive and disaster recovery? This is a classic term that everyone's paranoid about. How do we store things? How do we save things, right? This isn't the business of these customers. They just want to make sure that the data is safe and sound. So you get companies like NASDAQ who actually store the daily trading data on Amazon. We then handle the distribution of that to their subscribers for them. So they know, they can rest assured that when they put that data into S3, into Amazon, it's safe. And then we will take care of the deployment of that to all of their customers. And their deployment now means that their customers can rely on getting access to their data when they need it. That's a very efficient way for them to focus on their business, right? Using the elasticity of the cloud, they don't know how much data they're going to need projecting forward, but they can just keep throwing it at Amazon, we'll keep storing it, and we'll make sure it gets out to their customers. And they've written this custom app to actually help subscribers get the specific data points that they need. And you can imagine the volumes of data we start to accumulate when we collect trading data over several years for NASDAQ. This is one of our many, many customers. What about the fun stuff, all the games? Amazing statistics on some of these things. Makes you wonder between watching all the Netflix movies and playing all the games on Facebook what people are doing these days, right? They're all just watching media and consuming stuff online. It's insane. If you look at some of these very successful stories, this crowd here in Australia, Filter Squad, they came up with a great idea, and I'll show you a little video in a second of how that actually works. But the amazing thing to think of is that when you watch this app, 250,000 people downloaded it in 4 days. All right? Every one of those people that downloaded it ran the app and used it for what it's for. And what it does is it actually takes the apps that you're running on your machine, makes a little connection, and then it says who are your friends and what are your friends running. So click on one of those apps and you can see what your friends are running, so it recommends apps for them. Now think of that 250,000 times over in 4 days, how it's recommending to this guy, to that guy, all his applications, all his friends, and it's a big social network of app recommendations. Incredible volume. And they were able to handle all this traffic because the whole thing was running on Amazon Web Services. They didn't know how successful it was going to be. If they had known, they would have known to buy 10 machines or 100 machines or 1,000 machines. They didn't know. But with Amazon's elasticity, they were able to handle and absorb the traffic as it came in. Make sense? Great success story. We've got other application writers. For instance, in China, there's a company called Mobotap that writes this Dolphin browser. You should try it out. It's all gesture-based. So if you want to run Google, you just sort of swipe a G. If you want to run Hotmail, you swipe an H. Very cool. But they've got millions and millions of users all of a sudden using their system. The database is expanding like crazy. The data is flowing back and forth. They have to be able to ready to handle all this kind of traffic. And that's what AWS can do with Elasticity. Another good example is FunPlus Game, based in Beijing. These guys are incredible. They've got so many developers working on the cool games. They don't want to have people working on the IT infrastructure behind it, right? So this quote kind of sums it up. They went from 1 to 3 million users in just 3 months. One engineer controlled all of that environment. One very smart guy who knew how to run AWS. So he's managing all this infrastructure, and as the users and the game players are coming in, he's able to absorb the blow of all this traffic, right? And he's able to do that by managing it on the cloud. Very, very efficient. All right, let's talk a little bit about specifically what's unique about AWS. Hopefully by now you're thinking, well, how can I use this for my business? How can I run my systems? Whatever business you're in, how can you use that on AWS? The first thing we want to make sure that we provide always to our customers is the flexibility. We don't tie you down to any particular operating system, any particular language. Anything that runs on x86 can run in AWS. So you choose the platform that you're familiar with, and a lot of you have existing skills in Windows and Linux, etc. You can transfer all of those skills right now to Amazon Web Services. We're not expecting you to learn a new language or understand a whole new system. The actual use of the infrastructure is pretty straightforward to get used to. And once you realize that it's the same traditional Linux box, the same traditional Windows box that you've been using, you can just take advantage of that right away. Again, we don't tie down to any particular language type. PHP, .NET, Java, you name it, you can use that on Amazon just the same as you've been using the machine under your desk. Except now it's in the cloud, and it's in a scalable, elastic form that you can actually add more infrastructure when you need it, take away when you don't. So from a security point of view, this is often something that comes up as a big concern about the cloud. We've gone through all the efforts to make sure that we are certified and accredited to all the well-known systems. But let me explain our philosophy on security very carefully. We call it a shared responsibility model. What this means is that we will provide IT infrastructure, classic security on the first level, right? That's the physical stuff. You won't find any of our data centers with a big AWS neon sign on them, right? We don't describe where they are. We as employees are not allowed to visit them. There's no reason for Al and I to visit the actual data centers, so we don't visit the data centers. And we certainly don't let customers or anyone else visit them. So that's the first hardcore security level. Now you can imagine physically we've got a whole bunch of big ugly guards and they're protecting the gray walls and barbed wire fences and retinal scans and all that sort of thing. That's just the physical stuff, right? The next level is how we protect the infrastructure to you, okay? Everything that we do, everything we provide, for instance, the compute power, the storage, is by default protected that only you, the account holder, can see it. If you choose to expose some of that data, for instance, something in S3, you want to make sure it's available to all your friends. You are making that decision when you choose to make that piece of data, that picture, that video, or that website available to the world. So by default, it's all protected, just to the account, and then you come in and change it as you want. And that's why it's a shared responsibility model, because the final part of the security is you, the user. You've got to make sure that you're well understanding how you are opening up the doors to expose that data and expose that compute power, right? And we have a whole bunch of very detailed, very boring, long white papers that will describe to you how to best use Amazon Web Services in a safe and secure way, right? And of course, if you choose to encrypt something or run any software that you choose to whatever level of added security you want, you're welcome to do that, because only you have access to those machines. It's no good. Don't call Al and I and say, hey, I need help. You know, can you change one thing on my system? We can't get access to it. Only you have access to it as the account holder. All right. Then we'll talk a little bit about support. I think Al mentioned already. We've got several layers of support: developer, business, enterprise. A lot of these support levels entail additional data that we can provide you. One of the most exciting things we've released recently is our Trusted Advisor feature. And what this does is it goes through your systems and observes anything that we see wide open, right? Think of it like someone just going by your house once a day and looking, is that door wide open? Is that window wide open? We can make sure that we just point out to you things that might look a little odd. Gives you a bit of a heads up on some of those things where you could increase the security of your system. Okay? In terms of support, we have 24-hour support if you need it. And if you're going into a very important project and you want to have the available resources to make sure that someone skilled and technical is available on tap, you can sign up for that. In terms of pace of innovation, I talked already about this, about how there's a newsletter that comes out almost every week. We as employees have trouble keeping up with all the new features and products. It's very exciting to see how much innovation is going into this. But what we do with Amazon Web Services, we listen very carefully to the customer. You tell us what you need, we will work very hard to implement that as fast as possible. So we've built up over the last 5 years a set of services and features that address the needs of our customers. We're not running off in another direction building tools just because they're cool. We're trying to build things that you can use and you can actually make your life more efficient and take away that IT headache. That's the key thing. Can we make you more efficient to focus on your business without having to worry about the IT infrastructure? In terms of a global partnership, you'll recognize a lot of these logos on the left and the right. We've partnered with just about every single big major software vendor that has products that you might want to use. Oracle, IBM, Adobe, Microsoft, etc. All those products run great on Amazon Web Services. What's interesting about the way that you use those products now is that the licensing model changes. Traditionally, you'd have to buy a software vendor's license for a 1-year period or a 3-year period, whether or not you used it, right? And it's not like you could take it back a week after starting a project and go, you know what, we've changed our mind, you can have your license back, right? What we now allow you to do is use a lot of this infrastructure on an hourly basis. So the license is broken down into very, very small incremental parts that you're paying for just for that hour. So if it turns out to be a 1-week project, great, you're only paying for that week. If you turn out to use for a year, we're just going to charge you however much you use. Back to the pay-as-you-go elasticity, right? On the left, you'll see a whole bunch of partners that we've dealt with consistently over the last few years that have learned how to implement Amazon Web Services very efficiently. And those skills have been built up in a way that we can now partner with them to help you run your business more efficiently. They will help you to migrate some of your systems from where they are now in existing infrastructure into the cloud, into Amazon Web Services. We've got a very recent announcement. This came out just a couple months ago called AWS Marketplace. What this does is allows software vendors to put their wares up on Amazon Web Services for anyone else to rent or use or facilitate the use of that licensing on an hourly basis. So if you've got a cool piece of software, if you bundle that together in a pre-installed package, and I'll show you in a demo just how that works right now, you can take that package and offer it out to the world. We will handle the pricing, the charging. You choose how much you want to charge for it, but we'll keep a certain amount for the infrastructure costs, and the rest is yours. If you want to charge them $10 an hour or $20 an hour, whatever you choose, we will divide that cost up for the infrastructure and the software side. So it gives a remarkably global ability for you to portray your ISV package, your software, to the world and allow people to use it very efficiently. We're also evolving a whole bunch of training. We do technical workshops. Just to get you up to speed, this is a business introduction seminar, but we're actually doing several-hour workshops where we will actually take you through the steps of what I'm going to show you here in the demo. And soon we'll be offering architecture-style courses where you can actually come in for a few days and get really up to speed on Amazon Web Services and take those skills right away and start using them to efficiently move your headache from IT focusing on your business. That's the critical benefit that we're hoping to give you. All right, we're going to try something now. This is a demo. It's live, sort of. I'm going to show some videos of how you use Amazon Web Services very quickly. So if you strain your eyes a little bit, you'll see it. It's going to move pretty quickly. But I just want to give you an idea of how you're manipulating Amazon Web Services through a browser, through the web console. But bear in mind that what you're seeing here is actually just 10% of AWS's capabilities. The real value, the real magic of AWS comes when you can write scripts, you can use the command line interface, you can write apps that actually manipulate Amazon Web Services automatically through that programmatic interface. That's where you can really automate things. For instance, think about starting up a machine on Monday morning at 7 o'clock before everyone comes into the office and switching it off on Friday night at 5 o'clock when everyone goes away. Right? If you can automate that process, you've now saved yourself running those machines from Friday night, Saturday, and Sunday. That's a pretty significant gain in productivity and in cost efficiency. All right, so in this demo, what I'm going to demo is taking a pre-existing package. Someone's put a a CRM. We're just going to use an open source one called Sugar CRM. You might have heard of that. We're going to take a Sugar CRM package, and we're going to launch it in Amazon Web Services under our account and get access to it. All right? So here we go. We're going to start off by launching the machine in EC2. That's the compute side. We're going to assign an IP address to it so that we can access it on the web, and you'll see how it works. And this is pretty much real-time how it works. The first thing you'll notice that I do when I log in to EC2 is choose which region I want to run in. So up at the top left here, you'll see that we get to choose where you want to run that machine. And it's just as easy to start it in Singapore or in US West or US East or Europe. So I'm going to choose Singapore here, click Launch the instance. The next thing it's going to do is it's going to ask me, what sort of instance do you want to run? Do you want to run a Linux one or a Windows? What flavor of Linux? 32-bit, 64-bit, all just simple options. I'm actually going to type in Sugar CRM here to look if are there any pre-configured images that actually describe what I'm looking for. And sure, there's a whole bunch of Sugar CRM. I'm going to choose which one, and it's going to say which size do you want to run. So the initial machine could be a micro or large. I'm going to pick a medium machine. So I've picked a medium machine in Singapore, ready to go, continue. There are a couple of options you can tweak if you really want to, but we're just going to leave everything by default here. All right, I'm going to name the instance. So we're going to call it My CRM and hit go. Finally, it's going to ask me just to verify the security credentials. And this is a key pair. Remember I talked about the unique ability for you to control just the instance that you're on, right? So only you can access that machine. So once you've chosen that, you're going to choose a security group which says who has access to it and launch the machine. And off it goes. And probably within about 60 to 120 seconds, that machine is up and running. It's that quick, right? No need to call up a hardware vendor, no need to get a license set up, etc. So you can see it's pending right now, and within literally about a minute after clicking that original start, the machine is then running. So now that machine is up and running somewhere in the cloud. You don't know where it is, it's just running somewhere in Singapore, okay? We've given you a very long IP address, which is a very complex address on how to access that machine. But rather than go through that whole process, what we want to do is create what we call an elastic IP. We will give you an IP address straight away, within a couple seconds, if you need one. You can have as many as you want, and once you've got that IP address, you assign it to the machine we've just started in the cloud. That IP address that we've given you can now be associated with your company, mycompany.com, right? So that your URL, your domain, now points to that machine. And here we go, 46.137, etc. So if I take that IP address, pop it into the browser, and I'm connected. Machine up and running, right? And there you are. I can log into it, I can give a username and a password, and I'm running on that machine. Now just think about that whole process while I've been talking here for just 2 or 3 minutes. You probably couldn't even get your new server out of the box in time, right, or plug it in. So it's an incredible efficiency gain. We've got customers who have gone from requiring new machines and expecting to wait 4 to 5 weeks for that machine, and now it's 2 to 3 minutes. You can literally start the machine through a web console like that, or even through an API call that you've got scripted. So you can start 1 machine or 50 machines, okay? So that's the kind of fluidity or ease of use that you can actually begin new machines. And whether it's got Sugar CRM on it or any app that you've written or need to run, you can use that with that same kind of efficiency. All right, now we're going to talk about storage for a minute. You saw when that Sugar CRM image came up, all the chrome, they call it chrome around it, so the images and the logo and so on, right? If you took an image and you put it into our storage system, we're going to show you how to do that. You can upload 1 image at a time, sure. And in order to do this, I'm just going to create what we call a bucket. So I create a bucket in S3. This is our storage system. You choose where you want that bucket to live. Remember, we've got our regions around the world. So I'm going to choose one. I'm going to choose Singapore and create a bucket called AWS 101. Having created that bucket, I can start uploading content into it. Now I'm going to do one manually here. I'm going to click on upload. I'm going to click add file. I'm going to go find an image. This is from one of our evangelists that was in Shanghai a couple of weeks ago. So he's going to click on that image. I'm going to set the details on it. You don't have to change anything. The default, by the way, is no one can see it. I'm going to choose to make it available online, right? That's the big key that you as a user are making. So I'm going to change everything here, make everything public. In other words, I'm uploading a picture, but it's okay for the world to see it, all right? Click on OK. A few seconds later, it starts uploading it, and there's the file uploaded. Now, if we click on the file, it's been given a unique property. It's got its own unique URL, which is down here. And that URL, if I click on that, is simply going to open the picture. Now, that works great on my browser, but it also means I can share that URL with all of my friends around the world, and they can access it as well. And there's the picture comes up. Very simple, right? Now, obviously, you're not going to sit there and click upload for 1 million objects. But if you programmatically want to upload your whole system of all your PDF files or all your archived images or whatever it is, you can just pump them straight into AWS. And again, there's no charge for putting objects into S3. We only charge when someone takes it out. So depending on how many friends you got and how widespread you make that URL available, if you want to share that image with a whole bunch of people, they'll download it, and we will charge you only for the ones that are actually delivered. All right? Now that's all great because we put it in Singapore, which means my friend in Germany, who's now going to access it, every time he clicks on it, it's going to go all the way to from Germany to Singapore, get the object, and pull it back. All right? So now we want to show you just how easy it is to make this go global with our content distribution network. So using CloudFront, what I'm going to do is, on all these edge locations around the world, I want to tell Amazon, when someone asks for this picture, I want you to determine where the lowest latency is. Where's the closest edge location? And based on that, Amazon will automatically move the system's data from the original storage place to the edge location and then deliver it to the end user. So let's see how that works. So again, I'm going to go back into Amazon and choose CloudFront. That's the name of the content distribution network. And I'm going to tell it to create what we call a distribution. All right? So simply create a distribution, click on that. We've got two types. You can do a download distribution or a streaming distribution if you want to do streaming media. All right? What we're going to do then is select the bucket that's actually being used. Okay, so it's going to point at the one in Singapore. I'm going to tell it everything in that bucket now, all those pictures, make it available worldwide if someone wants to click on it. And you'll see what we generate is actually a prefix. If you put that prefix in front of the URL name of the actual object, we will take that as meaning, take the user's location, work out the lowest latency-based edge location around them, and distribute the content. So that's what we're going to do here. You can see this, it's a bit of an eye chart, but that's the actual prefix that we're going to use. Putting that prefix in front of the URL, and we'll try that in a browser. And click on that. And effectively, it's the same image, but now served to all those edge locations around the world, which is right there. So once it's deployed, the distribution's ready. We've now alerted all of our edge locations around the world. Listen out, if someone wants this picture, I'm going to do it. And there's the prefix in front with the same image file. So the image will be delivered that much faster. So my friend in Germany gets the image. That's great. But he tells his friend, who's sitting in Paris, which is just about around the corner, right? And again, that URL, the same one will work out where's the closest edge location and distribute it very effectively like that. Great. And just a note here, we're actually streaming this entire system today using Dux Media. So everyone online, you're watching us through Amazon Web Services. This is a company that's built a custom application together with Wowzer and using EC2 to actually stream all of what I'm talking right now through Amazon Web Services network around the world. Pretty cool. So we're using our own system for that. All right. What do we got on this CRM? Getting back to our Sugar CRM system. We've got an application running, but it's also got a database. And that database and the application are running together. What I want to do now is show you how we can separate the two. So we have the web server application running separately from the database. Okay? Diagrammatically, what this looks like is this. We've got our user, and he's accessing our compute system in EC2. And you can see both the web server and the database are on one system. All I'm going to do now is extract that and create an RDS master, Relational Database Service. This is where we really save you time. If any of you in the audience have ever set up a database, it's a hassle, it's a pain, right? The minute it's set up, it starts to get old. Why? Because the database version might go out of date. Have you done a backup? When's the last time you archived it? Is it in synchronized mode with whatever other copies you have, etc., right? We take care of all of that for you. And this is how easy it is. Remember how we started up the machine in EC2? We do exactly the same thing in RDS. So we literally click on start an instance, choose our flavor. Do you want MySQL, Oracle, MS SQL? You choose. You want to just define the version number, how big you want it, how big the instance is. And again, you can scale this, right? So if you're not happy with the instance, an hour later you can make it twice the size or half the size, right? Again, only paying for what you actually use. Choose how big you want it. I'm going to go for a 20 gig database here. And again, you can expand that later. Put in a couple of details about the size. Open up the port. Warning, at this point, you're actually exposing the database on that port, right? So you better make sure that you got your usernames and passwords and security set up. And once that's done, you're going to set up the backup, which is by default, it's going to back it up once a day anyway for you. Headache gone, don't have to worry about it. And you can create a snapshot at any time and restore from that snapshot. Having launched that, you'll see within just a couple of minutes, that database, which is going to run our CRM database, is now being created, it's backing it up, and then shortly it'll be running. And it's that easy. Once it's available, we've given you an endpoint where you can point all your applications towards. What this means is that if you've got any applications that use that database that was running on the same instance, you can now just point them to this edge or this endpoint, and we will take care of everything for that for you. Plus, it's backed up, and you can create snapshots at any time you want and restore from them. So the whole classic notion of worried about snapshots and something went wrong with the data, I want to go back to last Tuesday at 4 p.m., etc., all of that headache goes away. You can now immediately restore it without ever having to deal with tapes or backups or separate copies, or is it in this data center, is it in that one? All taken care of. Fantastic. Very big cost efficiency. Now, what happens when your system starts to get really popular? Now the traffic starts to increase, right? We've got this notion of read replicas. We can create additional copies of that same database in order to handle additional traffic load, so that you can have many, many users hitting the same database, but it's not going to overload that single database. You can always scale up by moving the database in size itself from a large to an extra large to a double extra large to a quadruple extra large with fries and so on. You can move that with scale up. But you can also scale out by creating additional read replicas. So we're going to show you how to do this. At the same time, you can actually create additional backups of the database running so that if one of them fails, it will fail over to another master. All right? So here we've got our original master database, and we've got read replicas. We'll show you how to create that. But then we can create what we call a slave or a backup or a standby, so that when the original master fails, if it ever does, we will then transfer control immediately to that one. So when the master goes out, we transfer it over. We call this multi-AZ. The reason is that the database itself, in the master, the original, was in availability zone A. The second one, which is a standby, we're going to put in availability zone B. So we've separated them out and made them redundant, but we've also isolated from the potential of one whole availability zone going down. If a fire was to take out that whole data center, transfer of control goes to the second data center, and immediately the control will go over. So it's a huge increase in redundancy. So let's see how easy this is. You simply log in, go to the database, and say, I want to create a read replica. This is the original copy to handle scaling. Right? You'd name that read replica, give it a name, say how big you want that read replica to be. And think about this from a flexibility point of view. If your traffic is really heavy on Monday through Friday, why not create a read replica to run Monday through Friday, but shut it down on Friday night? So you keep your core database running 24 hours a day all through the week, but you only create the read replicas when you need them to handle the increased amount of traffic. Same thing with multi-AZ. Simply going onto the database, you say you want to modify it. It was in one data center. One click, I'm going to change it from multi-AZ deployment no to yes. That's it. And then I'm going to tell it to apply that immediately, which means create a second standby in a separate data center right now, synchronize them and keep them synchronized, and make sure that if either one of them fails, it'll switch control over to the other. And again, think of the headache that it would require you to go through to actually buy a separate machine, find a different data center, synchronize it, set up the network, make sure that they're talking to each other, and then worry about them all the time. The efficiency gain in managing databases is incredible. We've talked to a lot of large corporations with very skilled database administrators, and some of them claim to be able to manage 20 to 30 databases. One guy managing 20 to 30 databases. We believe some of our database experts are able to handle 400 databases at the same time, because you've got this console ability to control the system much more effectively. Right? Okay, so that's really a very brief run through, but you get the idea of how efficient it is to actually move through the process with the web console. Now, to finish off, I just want to address a few cloud computing myths. I've been talking quite a long time now this morning about what we think of cloud computing, what Amazon Web Services is all about, but we still continue to hear some of these myths in the marketplace. So I just want to address some of them. People talk about the cloud not being reliable. Well, we've got a pretty different view of that. We think that Amazon Web Services provides a very good way to store your data in a highly redundant manner, in a very secure manner, which probably would cost you way, way more money, time, and effort and headache to achieve the same kind of results. One of the numbers we're very proud of is this durability. That's 11 nines, 99.99999. Now let me put that in real-world terms. If you were to store with us 100,000 objects, think of 100,000 PDFs or movies or pictures and so on, for 1 million years, you might lose one. That's the kind of durability that we're offering. Now, none of us is going to be around for 1 million years, and very few of us have 100,000 objects. But you can imagine, as Al said, we've now got 1 trillion objects in storage in S3 worldwide. Pretty impressive. That's enough for 142 objects for every person on the planet. It's a staggering amount of data that we have stored. How do we achieve that durability? A lot of people ask. When you give us a piece of data, a file, we don't just take it and keep one copy of it. We replicate it across availability zones within a region. So if you've chosen Singapore as your bucket, it stays within Singapore, but we replicate it multiple times. Then we continually go back and make sure that all of those replicas agree with each other. If one of them stands out as an error, has something wrong with it, we don't bother to try and fix it. We just throw it away and make another replica because we have enough replicas to agree with all the original ones. When you need the object back, you can get one of those objects straight away, and when you delete it, we delete all the replicas. So we can achieve what a lot of people wouldn't be able to, because if you had to set up a whole bunch of different systems, a whole bunch of different availability zones, different data centers to achieve that same kind of volume, it would cost you a huge amount. We can offer that in the same way as we do to our biggest customers like NASA or your company. We can offer you all of that for a very easy to manage price because it's not provisioned ahead of time. You're just paying for how much you actually store. Make sense? So bear that in mind when you think of this myth of the cloud not being reliable. Another question we often get a lot of people worried about security, right? We're not sure the privacy is adequate and so on. Well, again, we can go through very extensive white papers to show you how we have achieved our security, but we offer you the ability to fully control the data that you put in Amazon Web Services. We want to make sure that you make all the decisions in order to expose the data or to make it available or not to. So by default, again, everything is very, very secure. Everything is locked down to just your access. Happy to take questions on that as well. Finally, second to final, some people think they can build their own cloud. People you'll hear about saying, oh, well, I can do it myself. We've got a lot of IT specialists. We've got a lot of skills in-house and so on. Sure, that might be true, but think about this. The utilization of your infrastructure in-house will never be 100%. Because the minute you buy that hardware, it's paid for, but it's not being used. And if you plug it in and start using it, you're going to have to make sure that it's used all the time. The utilization of your infrastructure in Amazon Web Services is always 100% because you're only paying for it when you need it. So you can switch it off at any time and stop paying for it, right? So in terms of building your own cloud like that, take advantage of the infrastructure that we've built to actually run all of our systems. Amazon.com runs on Amazon Web Services, right? So you have this massive global retail online presence running on this huge infrastructure that you can take advantage of and use at the very low prices that we offer. It's actually amazing. It's one of the few companies, I've never worked for a company like this before, where I can work for a company that has lowered prices 16 times in the last 5 years. How do we do that? We continually lower prices because things get more efficient, hardware becomes cheaper, we've got more and more customers, we've got hundreds and thousands of customers in 190 countries around the world. And with all of that traffic and all that volume, we're able to lower prices more effectively for you. So whether it's a one-man startup or 100,000 people working for NASA, all of them can use the same massive infrastructure and take advantage of the huge system. Another myth we hear about is, oh, I'm scared of, I can't move everything to the cloud. It's too big a daunting task. We're not asking you to move everything on day one. Think about just a simple project that you want to experiment with. Move it into the cloud, gain confidence, try it out. Even if it's as simple as making one PDF available worldwide, globally, just like that, right? You upload it to S3 and you saw how easy it was to create a distribution, and now you're only paying for how much it actually gets delivered. Very, very efficient. From there, you might want to start a simple application in EC2, etc. You can move up the stack as you start to use AWS more and more effectively. But there's no need to move. It's not an all or nothing proposition. It's very easy just to start using AWS, gain confidence, and move on from there. Finally, we hear a lot of people saying, well, the cost isn't the only advantage, right? You might save time, but there's other things involved here. We believe that the things that people are not taking into account is how much more time you'll get to spend on your business. You can focus on your business. You can bring things to market quicker. You can be more effective in your job with your infrastructure taken care of, right? None of us worries too much about power and making sure that the water's running and so on. It just comes in through utility service. So we have the same notion with AWS. Think of the IT infrastructure as on demand, as a service. If you can rely on it effectively and you can get to use it, you can focus on other things. So the cost benefit is, sure, it's great, it's fantastic, you will save money, but think of all the added benefits that you'll get from not having to worry about IT infrastructure. All right, how do you get started? We've talked about this already. If you've got an Amazon.com account, go ahead and sign in. You've already got an account. If you don't, sign up for one. It just takes a few minutes. We will require a bit of information. We require a credit card, and we require a phone number. Because you and I have seen each other now in the room, but everyone online as well, we don't know you're a real person until you validate your account. You need to activate that account. So we will take your phone number, we'll call you, we'll give you a code, and you can activate that account right away. Now, if you're online, please go to the feedback form that was provided for you in the link. If you're here in the room and you'd like to fill out this form online, we'll give you $75 in AWS credits. Now, regrettably, you can't use those to shop at Amazon.com, but you can use them to offset costs of AWS. When you create a new account, you'll actually get a free tier, which means you can run on a micro machine for 1 year, 24 hours a day, which is quite a great offer. If you've got a simple website, running a few things, maybe a small database, etc., you can run all that free for a year. As soon as you exceed that free tier, with a bit of storage and transfer and so on, then you'll start eating into these credits. But with $75 in credits, it's quite a bit that you can start experimenting and using AWS. So we invite you to go to this URL or use the QR code and fill out the form there. We'd love to send you $75 to get you started. Okay? So with that, thank you very much for your time. We really appreciate you coming online and watching us there, and also in the room here. Really appreciate, as Al introduced himself, he's taking care of the whole area here in India, region described as Southeast India. So any questions and so on, give us some email. Thank you very much for your time. Really appreciate it. Thank you. We're going to do Q&A for...
Yeah, so we'll open it up for Q&A for a little bit. Just before we start on the Q&A though, just a quick housekeeping. You get these credits, just go to AWS, Amazon, have a free tier. It's not a free account, right? It's a free tier, but it gives you enough credits to actually start playing around with our services. You get 750 hours or basically a month free with either a micro Windows instance or a micro Linux instance. You get 5 gig of S3 for free, 15 gigs of data transfer for free. There's a 60-day free trial for RDS. Apart from all of this, for both the Oracle 11g, MySQL and MS SQL. So just start playing around with our services. That's the easiest way to learn. We are a self-service company. We have tons of documentation available on the website. We are, in that sense, we are very, very transparent. So you can get started. We will have 15 minutes for Q&A, but doesn't stop you from asking us questions. We will hang around after the event as well. We have our solution architect in the back who would pass around the mic for questions as well, and Kingsley and I would just take questions.
Go ahead. Do you want to hand those off? We've got a few more here. Yeah.
The first question actually gets a book.
Do you have any reference customers from defense and banking sector?
I'm sorry, do we have any what?
The question was, do we have any reference customers from defense and banking sector?
In the US federal government is our customer. We have over 100 agencies that now use Amazon Web Services. As described earlier, we have one of our regions totally dedicated. It's called a GovCloud in the US. We're very honored to have one of the quotes from Vivek Kundra, who was the CTO for a while for the federal government's IT infrastructure. And he felt that our IT security was as good, if not better, than when they were running the systems themselves under their own control. So that's a very good compliment to us that in the federal government department. Sorry.
Banking?
Yes, banking. We do have a lot of customers. regrettably, some of the customers don't want us to tell everyone that they're using AWS. This is an interesting point. There's some very well-known brand names that we can't disclose, but I can tell you that a lot of those customers are using us and they feel that AWS gives them an edge, and for that reason they can't disclose that they feel like they can't let their competition know that they're running us, even though we have several competing financial services on there. Bank Inter, we have a couple of popular ones at NASDAQ and so on that are using AWS. What I'd encourage you to do is go to our case study page. We've got a fantastic list of public references that we keep on site, online.
That's it, /solutions/case-studies. Or you can just go to the AWSAmazon.com page, and in the drop-down menu, you just find case studies. We have tons of them.
Another question?
Yeah.
Hi.
To send a large number of permission-based emails, I want to understand, see how you comply with the SMS laws and acts and all those things, and how I can make sure that it goes to the inbox instead of, say, spam folder or something. The second row, right side.
I'm sorry, I didn't. Could you just say the question again? Yeah.
Yeah, like see, if I want to send a large number of emails which are permission based, so where I get the user's permission to send the mails, but I want to make sure that it goes to the inbox instead of the say spam folder. So I want to understand, how you comply with the spam acts.
So you're saying once you've uploaded things into EC2?
No, sending out through SES.
Yes.
Wants to avoid being marked as spam.
How do you show it? That you're not spam. Okay, the increasing the deliverability, is that what you're talking about?
Yeah.
Yeah. So what we have done is we've allocated a whole bunch of IP addresses that we have registered with a lot of the spam filters. And those IP addresses are contained within a batch that we then use to send emails, right? We don't use them for any other purpose than SES. Now, when customers come to us and say, I want to send out 1 million emails, they should be legitimate, okay? We're not sending out spam on your behalf. But if your business is a legitimate business, we can then send emails reliably because those spam filters will say, oh, we know where this email is coming from. This is registered with a reputable company, right? It's very important, you can imagine, for Amazon.com to be sending emails that get delivered. Okay, we don't want to get our emails falling into spam filters. So we're using the similar kind of reputation, you could call it, of those IP addresses. Yeah. But if you want to, we can talk afterwards. I'll show you some of the white papers we've written on how to increase your deliverability and making sure that your email doesn't get folded into the spam folder. Yeah. Thanks. Come here.
Yeah.
L?
Yeah, good afternoon. I'm Suresh from Overdrive.
Yes.
In fact, we are in banking, software space.
Yes.
As per, regulatory compliance in India, we are not supposed to send personal information and financial information outside India.
Mm-hmm.
What is the step, you have taken in this regard? And second one is, we are, working with, we are an ISV partner of Sybase. They have come out with, cloud-based services now because after SAP has took over that. So we want to know whether those services are available. In the last meeting, I think some of people from your end were unable to give that information to me.
Okay.
And third one is there. Now Intel has come out with a hybrid kind of model. Whether it makes us more sense to go in this direction. 3 points are there from my end.
All right. Let me try and answer those in order. So the first question about data centers or containing data within India. Correct. We do not have infrastructure in India today. So if your regulation requirement is to hold that data within India, we cannot service that requirement. We simply cannot. Now I'll give you an interesting observation. We have customers around the world that use our data and use our data services in different ways. When I go to the Philippines, the customers there tell me, where's your data center? I say it's in Singapore. They say, good, take our data and put it there, right? We want it out of the country because it's safe, right? We have other customers that might require the data never enter the US, for instance, right? That's fine. We have data centers in Europe. We have data centers in Japan, in Singapore. We also have customers in the US who say the data should never leave the US, and we can handle those, but we can't handle places where we don't have data centers, right? So just an observation, but I joined Amazon 4.5 years ago when we were in US and Europe. Since then, we've added regions consistently every few months, right? If you look at where we were in Singapore 2.5 years ago, we've since then added a whole region in Japan and in South America. So we are expanding. We are adding in different regions all around the world all the time. Your second question was on the availability of certain services from within India, correct?
being an ISP of Sybase, no, we want to protect Sybase products. So we are always want to move with Sybase kind of platforms. Whether Amazon can able to deliver those services to us.
So can we protect the services?
No, whether we can able to get the services from Amazon.
Sideways. Okay.
Yeah.
Is that a special type of database?
Not only databases.
Sybase. Oh, sorry, Sybase.
Yeah,
okay.
Sybase. Say for example, HANA is a new thing which has come, and
Yes.
then Fuji.
Yes.
So these are the two products where we are deploying our applications.
Right.
Whether those products are available.
So we're adding services and products all the
Yeah.
time, and some of them are managed and some of them are unmanaged. Let me put a sharp distinction between that. If you look at some of the databases that we're running today under managed RDS, like MySQL, Oracle, SQL Server, right? Those are managed. You can run any software you like, even specialized software, on your own EC2 instances, but you're managing them then. So if you have something like Sybase or HANA, I've heard of HANA, I think it requires a lot of IOPS, right?
Yeah.
Very intense. We've just last week released a whole new instance family that handles very, very high I/O.
Okay.
So we could actually run certain use cases that we weren't able to run before. We're expanding our fleet all the time to handle different use cases like that. So if there's a specialized case of software and you have the license and you have the expertise, you can start a blank machine, a vanilla machine in EC2, and import that software and run it however you want on there.
Okay.
Yeah?
Yeah.
And sorry, I thought you had a third question.
In fact, Intel recently came out with an hybrid kind of system where it is offline cloud enablement is available in that.
Hybrid from a point of view of some in the cloud and some out?
Yeah, and then whenever we shift from cloud to non, that is whenever
Yes.
offline kind of mode, we can able to work with Intel products
Yes.
by paying that for offline services as well.
So we allow a certain hybrid model. It's very practical.
Thank
If you have regulations that require you to have certain data in your own data center, for instance, you spoke about keeping India, that's fine, but you can have infrastructure in AWS as well and connect the two of them together. We have an additional product called Direct Connect, and in that way we can provide you with a dedicated, private, secure line from your data center to one of our data centers. And that connection gives you the ability to basically create a virtual private cloud, VPC, in AWS, which simulates an extension of your existing network infrastructure on your own database or your own data center. So you can work out a hybrid model where you have part of your infrastructure in the cloud, part of it in your infrastructure. I think at the front
So
here,
just in the interest of time, I would request everybody to keep to one question. We have last 3 questions. I would hand out the questions to participants.
I have one question on the slide where you're talking about the backup of replica of the database.
Yes.
Now, in that case, if I start increasing the size of the database, how will I be charged on that? Because I may not be always using a backup.
Right.
So in that case, how is that? Is the storage going to be complimentary as a service, or it's going to be charged?
It's charged. We charge you double. Yeah. So if you have a database system running and it's costing, let's say, $1 an hour, it's a large system. If you want it to be multi-AZ, we'll charge you $2 an hour. But what you're buying for that process is a complete peace of mind that you now have a complete replica of exactly the same size in a separate availability zone. Right? With that one click, you're enabling not only double your charges, but you're also doubling your redundancy. Right? So everything is now set up to replicate asynchronously. Right? So it's actually kept current, so that if one of the systems goes down, it does flip to the other one. So that's what you're paying for. But yes, you're right. It does cost more. Yeah. And just a point about that, you can change the size of that dynamically as you want. If it turns out that the database is too big for your needs, just scale it down. If it doesn't turn out to be big enough, you can scale it up. And you can dynamically change that every few hours if you wanted to. So that's a very, very flexible model. Yeah. Thanks for the question. Hi.
Hi, this is Ajay from eTax. So we are basically a consulting and a training partner. So we closely work with Force.com and Windows Azure. So I mean, these all platforms have certifications for developers or administrators or consultants. So are there any certifications coming up for AWS just for the developers or the people using it?
So you're talking about pulling your data out of AWS or pulling?
No, he's talking about basically accreditations, training programs that we have for customers.
Right. We're working out more and more training programs. At the moment, we have a tremendous community that discusses these things in our forums, our online forums. If you're having a trouble with AWS, any issue that you're having, chances are that someone's already had it. So if you need support or you need help, go to those forums and check, because someone else will have come up with a solution and answered about it. But if you're looking for actual training on the specifics of AWS, we have workshops that we are running from time to time all over the world. We're expanding as fast as we can with smart evangelists and solution architects and so on. And we're also working out how to deliver a certified training program. So stay tuned for that, and you'll see some development on that soon. Yeah. But the best thing I can suggest is it's a self-service model. We have a tremendous amount of videos and blogs and documentation and entries online that you can get up to speed on. Yeah.
So the last question for the day, but fear not, we will stick around after this as well.
Hi, my name is Ashutosh. I had a few questions, but I'll stick to just one.
Okay, thanks.
So what if, how do you provide data liberation? So I have a lot of data in some cloud, Amazon cloud, and one fine day I decide not to use AWS and set up my own data center. I want all the data back on my data center.
Yes.
How do you provide that?
So you can pull out of Amazon Web Services within 60 seconds anytime you like. Right? We're not holding anyone hostage in our data centers. A couple of things. You can immediately cancel the account, shut down your machines, delete all your data, and walk away. But I hear your concern. You say, I've got tons of data in there, right? So let me tell you about one of our services called Import-Export. If you want to get your data out, you can pay for us to burn as much media as it takes, DVDs or whatever, and we will ship your data back to you physically, right? You can also download the data. I showed you how every single object in storage in S3 has a unique URL. You might not show that to the whole world, but you've got access to it, and you can download that data. So depending on how fast your connection is, you can suck it out at any time and take all that data out, right? But it gives me a good chance to tell you all about the import service, assuming that you want to stay with Amazon Web Services, which we hope you will. If you've got too much data to upload and it's taking a long time to put it over the wires, right? What we found is that sometimes it's faster just to get the data physically. So in Singapore, we call it the taxi last service. You literally get a huge hard drive, a 2 gigabyte service, right? Upload that into a drive and ship the data to us on that system. We will then take it, connect it into our systems, upload it to S3, and send you an email. Often within 48 hours, we can say that's available. So we can allow you to put huge amounts of data in and huge amounts of data out. Yeah? All right?
So on Instagram,
yes.
I want to move all my data from AWS to Facebook servers.
Instagram might take a while. Yeah, they've got several hundred petabytes. Yeah. Yeah. So something like Instagram, which runs 100% on AWS, right? That's a major investment they've made in our service, right? We would like to understand why they would like to leave all of a sudden. We hope they won't, because they're tremendously, beneficial to us and them. So I don't know why they would want to leave, but if they did want to, that could either be done, as I said, through a download service or through export. Yeah. But again, we're not holding anyone hostage. You can move that stuff out anytime you want, and your commitment to us is as long as the hour that you're actually running the machine. So there are no termination fees. Not like your cell phone when you quit your program halfway through and you've got to pay a whole big penalty fee. There are no penalty fee. There's no cancellation. There's no termination fee. So you can leave anytime you want, but hopefully you'll join the service and use it anytime. So thank you very much for your time. And again, Al and Joe and myself will be around to answer any questions. Appreciate it, and thank you very much online for joining us. Thank you. Bye.